So yesterday we started dealing with parallelograms. We were dealing with the sides and angles. And I mentioned, right, let me remind you guys, when we're dealing with the sides of parallelogram, the measurements were outside, right? The numbers were outside of the figure. Right? This is from yesterday. When we're dealing with the angles, the numbers are inside of the figure. So now, questions 21 through 22 here, I know I'm dealing with the angles. Right? The numbers are inside of the figure, and some of those numbers have a degree symbol. So I'm dealing with the angles, but now there's a segment inside. We call that a diagonal. I remember from yesterday, let's say I had a parallelogram here. If the angles were opposite, they were equal to each other. But now if they were adjacent, so let's say I was dealing with these two angles, those two angles are supplementary. That means add everything and equals to 180. So here, angle E and then angle F. I notice that angle F is broken into two pieces, but I'm looking at the entire angle F. Now, angle E and angle F look to be adjacent. So I'm not going to let them equal each other. I'm going to add everything and equals to 180. So let me just go. Let me change this to blue so we understand the difference. So I'm going to go 95 plus 4 plus 3x plus 54. And all of this is equal to 180. Okay. I know that I have to separate my sides with the equal sign so I don't get confused. On the left side of the equal sign, there's a bunch of things. So let me combine and let me condense it. When it comes to letters, I just see 3x. So positive 3x. When it comes to letters that don't have a number, I see 95 plus 4 plus 54. So I'm just going to call that 153. Notice I combine like terms, and I know all of this is equal to 180. I still want to continue combining like terms. The terms that don't have a letter, I'm going to combine them. I'm going to put them together. So they should be together on the same side. So this plus 153, let me move it over as a minus 153. Don't forget to switch the side. So on the left side, I just have 3x by itself. 3x equals 180 minus 153. That's 27. To solve for x, let me divide both sides by 3. So x is equal to 9. Let's take a look at question number 22. I'm looking at angle y, the entire angle y. I know it's broken down, but I'm looking at the entire angle y and angle x. Those two are adjacent, so I'm just going to add everything and equals to 180. So I'm just going to go 43 plus 51 plus 18x minus 4. And I know that all this is equal to 180. Let me separate them through the equal sign. Okay, the left side has a lot of things. When it comes to letters, I only see positive 18x. When it comes to numbers without a letter, I see 43 plus 51 minus 4. So literally I go 43 plus 51 minus 4, and I know that's 90. And all of this is equal to 180. So when I combine like terms, this plus 90, let me move it over as a minus 90. Don't forget to switch the sign. So I have 18x is equal to 180 minus 90, 90. Okay, let me divide both sides by 18. 90 divided by 18 happens to be 5. Okay, so that's not that bad. Let me flip the page. Let me take a look at question number 23. Okay, so now here, we're looking at the diagonals, but Mr. Leonzo, I don't see the angles. Okay, here we're looking at the measurement of the diagonals. One cool thing about measurement diagonals in parallelograms, they cut each other in half. Okay, so what does that mean? You see how the diagonal, there's a diagonal EC. Well, there's another diagonal. Let me do it a different color. BD. They cut each other in half. They might not be the same length, but right, the diagonal EC and the diagonal BD, they might be different. When we're dealing with parallelograms, they can be different sizes, but the cool thing is that they cut each other in half. I see some information given. Okay, so let's see. KE, so the length KE is 22. So KE is this. Before I continue reading, I'm going to say KC, it's also 22. Remember how I said that diagonal was cut in half? All right. So I always start with the information that is all numerical. KE is 22. So I find out what's KE. Okay. And I know it was cut in half, so 22, 22. Now, let me take a look at this last thing. CE, the segment CE is 5x minus 1. All right, so if you were to connect from C all the way to E, how big is that? Well, 22 and 22, isn't that 44? So let me write this as 44 is equal to 5x minus 1. I know the measurement CE is 44, so I just wrote it as 44 is equal to 5x minus 1. My instructions will be solve for x. Okay, so this is just a simple algebra question. This minus 1, let me move it over as a plus 1. So that gives me 45 is equal to 5x. Let me divide both sides by 5. So 9 is equal to x. X is equal to 9. Not bad. Looking at number 24. Again, I start with the side that is all numerical. The segment VX is 28. Okay, so from V all the way to X is 28. But remember how I said that diagonals get cut in half. So I'm going to say this side is 14. And this side is 14. I know the whole thing is 28. So I cut it in half, 14 and 14. Now let me pay attention to this. NX is 2x plus 14. NX, if you see it, just that. So I'm just going to say 14 is equal to 2x plus 14. Cool. Not too bad. I want that 2x by itself, so this plus 14. Let me move it over as a minus 14. 14 minus 14 is 0. So 0 is equal to 2x. Oh, Mr. So there's a 0. So what? 0 is a number. Let's divide by the number in front of x. The number I see in front of x is 2. So let's divide both sides by 2. Let me do the right side first. 2 divided by 2 is 1, 1x. Cool. Now the left side, 0 divided by 2. 0 divided by 2 is 0. So 0 is a number, so what's wrong with it? In this case, x equals 0, so my answer will be 0. Don't get confused with zeros. Okay, so that was not bad. Make sure, notice how 23 and 24, I started with the side that was all numerical. Make sure you start with that side as well.